Hi, everybody. This is Shanti. Alexandria and I are going to teach you about fractions today. We are on chapter 14 and 15 in our textbook. And here we go. What we will learn today is Developing Fraction Concepts, chapter 14. This is what I will be going over, and then Alexandria will be going over and putting it into play. First, we will be understanding fraction constructs, understanding fraction models, understanding foundational concepts of fractional parts, in other words, partitioning and iterating, understanding equivalent fraction models will be our last part, and then we'll do a little activity at the end. But first, we are going to watch a little video about fractions.
There were 5 pieces in one whole pie. The denominator of the whole pie was 5. The numerator of my part was 3, as 3/5 of the pie was for me. My mom made the apple pie out of Granny Smith's. She asked me if I liked it. I said, I plead the fifth. The numerator's the car. The denominator's the whole. And fractions are parts of a whole. 3 birds were on a telephone pole. The denominator 3 was the group as a whole. The numerator 2, out of the thirds, described the 2/3 that were bluebirds. The numerator 2 described how many were blue. Then something fell on my head. It was bird poo. Bird poo. The numerator's the car. The denominator's the whole. And fractions are parts of a whole.
I took 4 shots on the goal. 3 went in, but 1 hit the pole. The denominator was all 4 shots. The numerator was the 3 goals I got. The other team's record had taken a toll. I got 3 points on my shots and 1 Olympic gold.
The numerator's the car. The denominator's the whole. And fractions are parts of a whole. A number line is every fraction between 0 and 1. Right in the middle is 1. Half of 4 is half of that. A fraction's parts you realize have to be the same size.
Hey, we're late for the game.
Hate to leave you guys. Visit numberrock.com for exclusive.
Well, I hope you guys enjoyed that video as much as I did. It makes fractions not as scary. I know that a lot of people do not like fractions, but they're not as bad as you think. And Alexandria and I will help you to get over that fear of fractions, and you will learn to love them. So let's get started. Fraction constructs. There are 5 different constructs for fraction. The first part is part whole. In the part whole interpretation, the denominator shows the number of equal parts in the whole, and the numerator shows how many of those parts are included in the particular fraction. The part whole constructs often represented with an area model, such as a shape partitioned into equal parts. I have a great example right here. The area of this triangle that you see right here has been partitioned into 2 equal areas. The fraction would refer to the one part out of 2 equal parts of the area of the triangle. So you have 1 as the numerator, and the whole would be the denominator. So the whole triangle, denominator 2, and then you split it in half. So they shaded in the triangle, just half the triangle. So that would be the numerator. Measurements. Oops, sorry. Measurements involves identifying a length and then using that length as a measurement piece to determine the length of an object. For example, you have a tape measure, right? Many of us have seen tape measures and they see all the little lines on there, see all the fractions. That helps us to measure. For example, the fraction 5/8. You can use the unit fraction as this 1/8 as a selected length and then count or measure to show that it takes 5 of those to reach 5/8. This concept focuses on how much rather than how many parts, which in that case is part whole situations. Fractions constructs continued, and we'll get into division. Fractions are just another way to write division. If you have a fraction like a half, it's the same as dividing 1 by 2 or splitting the 1 into 2 equal pieces. This is proven when we write out an equation. If we multiply a half by 2, we get 1, because if you have two halves, combining them would give you 1. In Alexandria, I'll be going over division, give you a little better understanding of it. But here is when you divide a single unit, the unit is broken into equal sized pieces. So you have the whole, which is 1, and then you divide it into 6 pieces. 1, 2, 3, 4, 5, and 6. And same with these. You have a whole, which would equal the 1, and then they've divided it into 4 equal parts. And then same with this, 1 divided by 8, and there's just 8 pieces right there. The operator, when a fraction of the amount is required, the fraction acts as an operator or function on the amount. The original amount is multiplied by the numerator and divided by the denominator. And we're not going to touch base on the actual multiplying or dividing any of that right now. We're just getting the foundation. So a fraction acts as an operator. Right here you can see 1/2 of 2 is equal 1/2 times 2. Of will be the times, the multiplying, and it's equal to 1. So then our last area for the fraction constructs is ratio. You won't be talking, or we won't be teaching you really about distinct mathematical this concept until the middle school years, but you will encounter it, sooner than that, just not in depth. We'll go over equivalent fractions, and those express the same ratio. Equivalent ratios, which are in effect equivalent fractions, are two ratios that express the same relationship between the numbers. We can create equivalent ratios by multiplying or dividing both of the numerator and the denominator of a given ratio by the same number. So here is a great example. The ratio of 2 can be represented as a group of 2 squares. So you see the 2 squares right here. And then you also have the 3 triangles. So the ratio of 2 to 3 can be represented as a group. This is the group as a whole. 2 squares compared to a group of 3 triangles. So you're comparing the two, and that is a ratio. So the next area we'll go into fraction models. I think this was kind of my favorite area, and we're going to be doing an activity at the end where you get to do a little bit of the model work. Fraction model concepts and how they compare. So you have the area and what defines the whole. The area is defined as the region, and what defines the parts? The equal parts. The equal area, sorry. What the fraction means, the part of the area covered as it relates to the whole unit. So you've seen the length in the number line. We have a number line right here and a number line right there. The unit of distance is or length, and what defines those parts, the equal distance and the length. The location on the point of a relation to 0 and other values on a number line. So again, here's the number lines right here, great example. And then we have sets, and the next page we'll get to look at that a little bit more. Whatever value is determined as one set is what defines the whole, and the equal number of objects is what defines the parts. So really, they're all very similar. I forgot to tell you this. So for this set, what the fraction means is the count of the objects in the subset as it relates to define the whole. So partitioning. This is where you're sectioning a shape into equal size parts. It's called partitioning. A great example would be a batch of brownies. We all love brownies, but we want to make sure we all have enough. There's enough for everybody. When a brownie has been partitioned into 4 equal shares, the parts are called fourths. The whole batch is into 4 parts. All the parts are the same size, fourths. So there are 3 types of partitioning models: area, length, and set. So here's a great example of the area model. You have the pattern blocks, and then there's the area, it's all filled in. Length model, again, all filled in, and then cut into sixth. And then same with this model, the set model. You have a set and they're cut into 6 again. So iterating. Counting fractional parts is also called iterating. This will help you to understand the relationship between the parts. The numerator, which is right here, this is the one is the numerator, and the whole, which is the denominator. I like to memorize the denominator as being the dominant one, so it's the whole. One image for thinking about fraction is iteration. To conceive of a fraction from iteration perspective, first you start with the unit fraction, such as 1/5. How can you tell if something's 1/5? Well, right here is perfect example. You have the whole. This is a whole. And then you cut into 5 equal pieces. So you have 1, 2, 3, 4, 5. So that makes 1/5. So the amount of 1/5 copies of its equal 1. The image here is taking 1/5 and iterating it 4 more times to make it the whole. Here's another partitioning continued. Partitioning consists of creating smaller equal size amounts from a larger amount. So again, we can go back to the brownies. With brownies, we had the whole pan of brownies and we cut them all into, in this case, 5 pieces. So here's a piece for me and there's a piece for each of the students in the group. Iterating consists of making copies of a smaller amount and combining them to create a larger amount. So again, here's the whole, and then you're making into 5 pieces. Okay, equivalent fraction models. Equivalent fraction models are 2 fractions are equivalent, equal if they're the same size or are at the same point on a number line. Equivalent fractions represent the same amount of distance or points on a number line. So here are great examples right here of that. Here's half, 2/4, 3/6, and 4/8. And then we are going to go ahead and our next section, we are going to do our activity and it's ways to represent a fraction. We're going to kind of go over exactly what we just learned about, give you a little foundations and see if you learn from that foundation that I just went over. And then Alexandra is going to finish us off with the actual multiplying, dividing, adding, and subtracting. So just hold tight and I'll go ahead and we will do this activity.